separator. So this is one that you probably won't come across too much unless you happen to live in the boonies, or like in a country like Australia, which has admittedly very old buildings which have bad electrical standards. So, but I thought I'd do this one quickly. One sec while I get everything set up. I only just got home, by the way. Like, literally just walked home through the door, grabbed a beer. Alright, so I had a bit of fun yesterday. I had a fuse fail. And the type of fuse I'm talking about, I took it to work for reasons, because I could grab some tools from stuff from work that I'd need. Like WD-40, some electrical contact cleaner, some steel wool, a couple of different types of tools that I use for scratching and basically polishing. Hey Tick Tick, there you go. Hey, get down. Don't tick, I'll give you attention soon. Okay. And this is the culprit. So basically, when you live in a humid environment, especially if you have old style fuses, never assume that they're doing what they're supposed to do. So I'm talking about what's on your electrical switchboard. So say something like, for instance, like this. In other words, an ancient style electrical, distribution unit. I mean, it does look like it's got an RCD on it, but other than that, it's got fuck all. Now, when you have a fuse fail, there's a couple of different things you can do. One, the first thing you do is you go out and find out which fuse has failed. So in my house's example, I have one on my stove. I have one on each side of the house for my power outlets. I have one on my lights, and I have one on my hot water system. And basically what happened is that the one which was on the side of the house where I have my computer, my aircon, my fridge, my modems, like, my actual internet sort of stuff, as well as my, did I say aircon already? Probably. Anyway, so in Australia, the standard, and I'll show you a close up, but you probably can't read it. Yeah, I definitely can't read it. But anyway, this says that it's a 15 amp fuse block, and it's an old ceramic type. Now, basically what happened is that this fuse, for this section of my house, sits right next to my stove's fuse. And depending on how much current you're drawing through them, they shouldn't ever get hot. Basically, the purpose of a fuse is so that if there's too much current being drawn, that it will melt. Now, what happened here is that I've been running a vacuum cleaner, a computer, an aircon, a fridge, everything in my house off one 15 amp fuse that, when you do the math in terms of watts to amps, is about 3,500 watts. And basically, if I'm pulling more power than that, it generates a bit more heat. And the thing about fuse blocks is, because they've got a little wire, usually. So there's a little wire that goes from one post to another. Now the difference between ceramic blocks and the sort of like RCDs or whatever that you plug in or have wired into a normal switchboard is, wired fuses have a bit of a delayed response time. It takes about 10 seconds above the rated, sort of like voltage or amperage, should I say. The voltage is different from amperage. It takes about 10 seconds for that wire to actually melt. Now, what I discovered with this one was, when I went out and checked it after I finally tripped it, someone had run copper wire from one side to the other. Copper wire. It wasn't even fuse wire. So that could probably potentially take up to 100 amps before it blows. And the wiring in my wall, because it's an old house, I can assure you, is not rated to take 100 amps. So I'm extremely lucky, basically, that this actually tripped with a copper wire fuse wire in it. Basically, it'd been sitting in there for that long and had been exposed to the elements that much that the wire was weak enough that when too much power was being pulled, it actually got degraded. Extremely lucky. This fuse was so hot to touch that I couldn't pick it up by the porcelain or the ceramic on this side for longer than about 2 seconds because it was burning the fuck out of my hands. So basically all I did was I switched that breaker off, yanked this out, because like basically just felt the front of the fuse panel that I showed you before, because I knew that this or the stove was the culprit. And yeah, it's very, very lucky that I didn't have a house fire. Anyway, so most of these ceramic blocks should be updated and upgraded by now, but they aren't all. And when you move into a rental or whatever, like I have, like this particular rental, you can't trust that the person who was living there beforehand doesn't know a fucking thing and puts the wrong fucking fuse wire in. Because that's exactly what they did. They put a 36 amp fuse wire in, so it was running way, way too hot. I'd rather I'd have the fuse trip than I burn my house down. I'm sorry. Anyway, so what I did, and this looks a hell of a lot better than it did when I pulled it out. It was black on one side and burnt. Okay? It's very hard to get these because they don't build them anymore. You can't buy them in Australia because it's not decode. Essentially, if you call out an electrician to put in a new circuit and they have to run one off one of these, they won't actually do it without replacing the entire switch panel because these are so dangerous. But they're also good in a way, and I'd like to just explain their benefits versus like an RCD or something like that just to start off with. And I'm probably using the wrong terminology, but still. If you have a short circuit on the wires in your house because a rodent chewed through it, and you're using one of these which has got fuse wire in it, what happens is the fuse wire evaporates. It's gone. So when you pull your fuse, because you know the fuse is tripped obviously, when you pull the fuse and you look at it, it's like, oh, where the fuck's the wire? Oh, I see, something's been eating into my wiring. If you see just like a little bit like in the middle with like globs on each end of the wire, then you know that it's more of like an overcurrent thing, so you're using too much current. This third scenario is when you have these blocks, and these are 30, 40 years old at this point, and the fuse wire in them is so old, being exposed to the elements and everything like that, that it goes black and carbonized, usually on the negative pole, or sorry, positive pole, sorry. especially if you see it on one side, that's when you know that it's old and it's just been going for way too long. Either that or it's shorted, but in this case it wasn't because the wire didn't explode. But that said, the wire wasn't fuse wire. Someone literally ran copper on this thing. So I recommend if you ever move into a house, even if it's a rental, turn off the power, pop the fuses, make sure everything's isolated, pop the fuses, and just have a look at it. And just see what sort of condition they're in, because I never thought to check this. And I should have. Because I could have burnt my house down yesterday. Anyway, so grabbed a couple of tools from work, so I'll just show you what I did. It's on this side, mostly. So usually it's sort of like a brass with a copper coating, or like whatever. And you have screws, usually. Different brands have different things on it. So this one in particular uses a screw. So more like a bolt, I'd say, rather than a screw. Nearly dropped it. And it's got a flat metal piece, square, that interfaces with the side of the block when you're tightening it up. This is the biggest culprit when you come to hot boxes. So in other words, if you've got a circuit breaker which is generating too much heat due to age, it's usually due to carbonization of the metal from exposure to overloaded currents. In this case, it's because I'm running an aircon, a computer, a fridge, and everything else off the one circuit. Right? So it is being overloaded. You need to get this and clean all the carbonization off. Because where the wire, which is the actual fuse wire, which goes from each side of the block to the other, where they actually connect to the block, that carbonizes over time. If it's like 20, 30 years old, which this one was, that connection between the wire and the actual terminals that go into the back plate of the switchboard, circuit board, or whatever you want to call it really, those will become carbonized over time, and what ends up happening is you have increased resistance between the wire and those terminals. So all the electricity in your house, running all of your shit, runs between that, a little piece of metal, and a little piece of metal, through a tiny little wire to the other side, which is exactly the same thing. Need I say more? Basically, this is just something that, if you don't have any electrical knowledge, feel free to get an electrician to fix it. But this is classified as a repair, so I'm legally allowed to do it. Also, I have telecommunications experience. I used to work with up to 110 volt every day, so I know a little bit about it. But anyway, if this is bad, you can fix it. As long as there's no cracks in the ceramic or anything like that. If what you're plugging this into is bad, only an electrician can fix it. Because even if you turn off the circuit breaker, you don't know if there's live voltage being fed in through like an earth or something like that. And you could sit there being with one of these and a bit of steel wool trying to clean out the terminals or the block or whatever that slots into inside the back of your actual circuit board, like a switchboard, whatever, switch panel. And there could be a live current there. So never ever do that unless you are a trained electrician. I won't do it personally. I don't, because I might be trained as a telecommunications engineer, but I'm not a trained electrician. Though, you've got to use your brain in these things. Plenty of people have killed themselves doing it, thinking they can do it. Anyway, so what you do is, once you've got these blocks off, you take out your screws and your whatnot. Combination of a good old WD-40, steel wool, and elbow grease, and usually something like one of these. You can get steel wool and basically push it, because on the inside is where it actually interfaces, not on the outside, right? And use steel wool to clean on the inside of those contacts, because that's where it actually interfaces. And also, you got to be careful. You don't want to drown the block, so don't do it while it's on the block, because you might end up with a block that's covered in oil that can catch on fire. Okay, you want to be able to clean it afterwards. After you've given it a good clean, a good scrub, and removed all the carbonization, in other words, changed it from being black back to brass or copper. In this case, most of the copper is already gone, but it's still conductive enough. It's the oxidization that removes, or carbonization that removes the ability for it to transmit current without resistance. And that resistance is what generates the heat. So if you've got multiple blocks doing it, you need to clean multiple blocks, but you can clean multiple blocks as long as they're not cracked, because that's a hazard. And that's a standard repair in electrical. And a lot of people don't realize that a lot of houses, especially if they just go to the RCD, if they see a fuse flick, they just flick it back. You know, a lot of houses still have these old blocks, and they are better in some ways than RCD blocks, or like basically, you know, essentially. They are better in a way, but they're a lot more dangerous, because if you don't know what you're doing, you can kill yourself. And not to mention burn your house down. So, anyway, after they're cleaned and you've got all that back fixed, and don't forget to do the screws and the back plate as well, because, and what I do is I get a sharp tool, like say a small hex head screwdriver, right? A small hex head one, and I use the carbon fiber. Well, not carbon fiber, you know what, carbon steel. And I scratch as much of the actual contamination off the surface of the metal as possible. But keeping in mind, you don't want to gouge the metal, because it's got to be a flat surface. It's the same as when you're thinking about, like, say, a computer CPU. It's like lapping. You just scratch it until you can see metal again, essentially. And that should reduce the amount of resistance that is being experienced by that block. Anyway, bear with me. So the next part in the lesson is depending on where you live, there are different amp ratings for different circuits, and it doesn't have anything to do with what's plugged into it. If you overload a circuit, the fuse is designed to trip it and stop it so that it cuts out before it supplies too much voltage or amperage. The reason for that is in a lot of old Australian homes, for example, they used to use imperial gauge wiring. So imperial gauge is like 1 over 034 or whatever. You know, just throwing a random number out of my ass. So they didn't measure it in mil, which means that the new circuit breakers and everything that you can get from Bunnings don't match up precisely with what the household circuits have been designed to do. So, but the usual standard in imperial wiring in Australia was 8 amps for light circuits and 15 amps for power switch circuits. So in my case, half my house is on one 15 amp switch, and in the other half of my house it's on another 15 amp, well, fuse, should I say. Now, where you can run into issues with that is if you go and get one of those clip-in, breakers that just pop into your ceramic fuse thing and are supposed to fit. One, you might not make good contact with the contacts between this and the actual backplate. And this is a particularly good example because these are Wilcos. These aren't, what are they called? Fucking Legends, or anyway. there's a couple of really generic ones. If you try to use 16 amp circuit breaker on an old style wiring setup, it can't actually handle 16 amp. It's like topped out at about 15, and you actually have to go down to 10. So the next one down from a 16 amp circuit breaker is a 10. And you try to imagine running a 2000 watt off one plug. You know, like you can't even run a vacuum cleaner basically. So some of the old Australian wiring especially can't be fixed like this. You have to know what you're doing. Like you can't just grab a 16 amp circuit breaker and go, you actually have to fix this. And the other thing I've got to point out is, if you don't know what you're doing, don't do anything, ask an electrician. You've got to know exactly what sort of wiring is in your house, how thick it is, the gauge, the cross-sectional area of the copper in your wiring, whether it's 1 strand, 3 strand, 7 strand, and that's how you tell whether or not it's old or new. Old stuff is usually 1 or 3 strand, new stuff is usually about 7 strand. Anyway, I'll stop waffling and have a beer. If you've got anything to say in comments, please let me know. I'm not going to finish the video just yet because I'm going to repair this fuse block, rather than getting an electrician out and costing my landlord thousands. Hey Rocky, how you going? Long time no see, brother. So I'm just going to quickly do this up by hand, finger tight, before I get to the next part of it. Well, I started dating a girl in Malaysia. Rocky's just like... Still carrying on at work. Thank you. Yeah. She's actually awesome. Oh, these cars, they annoy the crap out of me. I don't like stressing the metal. And that one's just like done up so tight I actually need to break the card to get the metal out. So basically what you want to do, and this is like kind of the same sort of stuff I used to do when I worked for Telstra, was probably want to cut off a length. The way I usually do it is I actually feed it through the whole system first, because I know exactly how much I need, and that way I don't waste any. But feel free to cut off a length when you do it. Alright, so pair of pliers. And what you want to do is you want to wrap that around, and on this block it actually goes back through the back and then underneath and then back through this side. So in this case I actually want to do it sort of probably need a bit more. This is where it gets fiddly. These blocks are fiddly because they're backwards. And you actually have to take it completely out to be able to do it. So this is 15 amp fuse wire. This is basically your standard sort of like house circuit. And all you want to do is you want to get a clockwise wrap around it about 3 times. Or more if you can get away with it. And you can do that fairly simply by leave a little bit of extra so you can cut off any dangly bits. Oh, don't want to lose my screw. Oh shit. And oh yeah, that's the other thing. I gave it a good clean after I WD-40'd it with some electrical contact cleaner. And then wiped it really heavily down so that there's no sort of like electrical sort of transmission. Oh, you're kidding. I keep on dropping it. I'm going to drop this on the floor and make it full of myself. It's been a while since I've done any wire wrapping. So I'm just going to grip that with my hand. Once. And I'm using my fingernail to actually get it to go around. Yeah, so 3 wraps. Don't do less than 3. That will make more sense in a bit. So once that's wrapped around like that, that's when you can cut it. And you want about 3 times the length of the block, just to make it safe. I mean, you're only going to waste wire if you do it wrong. But always make sure you do it right. So I've got 3 times around. I'll pull on it a little bit just to tighten it. And I'll cut it. Very close to the actual screw itself. You don't want dags hanging out, but you do want to have that cut off very close. And you want it wrapped around at least 3 times so that when you pull on it, it doesn't unwrap. Then feed it through the mechanism of whatever type block it is. In this case, it's a little bit different from a standard Legend one or whatever, or Champion or whatever it is. And you can break the wire when you're doing this, so try not to overstress it. Alright, there we go. Got it on the other side now. And yeah, basically once you've done that, chuck this back on. And as I said, you want to make sure that this is fairly clean, so scratch it until you can see metal. I left a bit of it just so I could show you how to do it. Because all that carbonization, it's not conductive. And that's what causes the majority of the problems when it comes to this, is it's got to be conductive. And I've just scratched off rust, shitloads of rust. A bit of electrical contact cleaner into it, just to make it easier to clean it. Doesn't need to be like a perfect sort of like copper color, but it does need to be kind of like, you need to be able to see the shiny. And that's the precise problem that was wrong with this circuit before. is that it was just trying to transmit its heat, you know, its energy essentially through carbonized metal, which is basically a resistor. These are the sort of skills that a lot of young people have lost because they just think that everything should work. They don't understand how it works. So yeah, you've got your iPhones and your gadgets and all that sort of shit. But like, learn how the electricity in your house works. Maybe we will save yourself from having your house burned down one day. Perfect. I'll just grab a cloth, and now that I've done that, blast the crap out of it. Right? Because this is what you want to be able to make good electrical contact. And good electrical contact cleaner will ensure that there's good contact. So chuck that in there like that. Grab our trusty little screwdriver. Tighten it up. Because this is a semi-insulated block, that bit of wire, which is going through there now, that can carry all the power. That tiny little wire carries the power to half of my house. That's why you need to be so careful. Okay? To do it right. And a lot of things like this, don't over tighten it. It's got to be like just a tiny bit loose, like on the tightening sort of side of it. So like, if you can't tighten it with more than 1 or 2 fingers on your screwdriver, you know, don't do it more than that. And that's good contact. That will make a good circuit. And some of these also, you got to make sure it goes straight. Some of them don't always go straight. So they'll wiggle. If they wiggle, it's not tight enough. But then again, more than 1 finger, too much. Though I could move that with 1 finger. But then again, I do this. So, same thing on the other side. Clean down this plate. Make sure that you remove all carbonization on, most importantly, the inside of the contacts, where it actually contacts the back, and as much as possible towards the other side where the actual screw and the bolt goes through. And again, same thing. The surface that you use needs to be shiny. I've already done this once at work today, but I know that sometimes it takes a while for it to soak in, for it to work. So I started earlier today, let it sit for a bit. Now I come back and it's coming off. Earlier today I wasn't having much luck with it. And again, you just want to scratch it, get it nice and shiny. You don't want to gouge it too much. It just needs to make good electrical contact. You live in a place like mine where basically we live in subtropical conditions. These things go black from not just corrosion and heat, but also the salt. Well, I suppose it's also corrosion, but also the salt in the air. If it's black, you've got to clean it. Again, electrical contact cleaner. I mean, it's not going to be as good as a new one, but that's the thing, you can't get new ones anymore. So the ones that exist, you got to maintain them. Unless you want to redo your whole circuit board, which I actually recommend. I recommend that rather than doing this, you get a qualified electrician to come out and replace the whole fucking thing. Because they're bloody dangerous if you don't know what you're doing. And in bad circumstances, like when they get old, you do need to replace them. When they get old, they don't just fail and they don't work anymore. When they get old and they fail, they burn your house down. I had a good chat with a person at work today about it, actually, because like we both understand it. And yeah. So anyway, back around clockwise. It's a lot easier when you're doing it on the other side. I can do it by hand. 1, 2, 3, and cut. I wasted about an inch worth of wire. And don't accidentally cut through the wrong one. I miss my old little Lindstroms, which I used to use when in my electrical work, because they were probably the best pair of electrical cutters I've ever owned. Anyway, so yeah. Where did I put the little spare bit? I've lost my bits! Oh, there it is. So you can compress it a little bit, but you don't want to over compress it. That's why I use 3 turns, is because it forms a coil. When you actually tighten it up, it will compress it, but you don't want to over compress it, and it will stop naturally once it's good. Hey Zanzam, how you going? Alright, that's perfect. 1 repaired ceramic fuse block. I'm quite happy with that. What do you want to bet when I plug it in my house burns down? From Morocco, bruh. Okay. Nice. The other thing you got to worry about with these guys, beyond like having to clean the bloody living shit out of it, especially when they get oxidized or carbonized, is that the actual teeth on them, where they sit inside and they clip around the block or the rod or whatever it is, they can expand. So you can flex them in just a little bit, just to make it so that they have more spring in them, essentially. But obviously these things have a half-life. Eventually my circuit panel will have to be upgraded. But this keeps the landlord or my real estate agent off my back for another year. And Nobody has probably even done this in like 10 years. Check all your fuses. As I said, my house nearly caught on fire yesterday because this fuse was sitting right next to one that was running my stove. And the stove one overheated. The stove one's not as bad as this, but it's getting bad. But this one running with all my other gear as well, that was nearly a fire. Anyway, I'm in Australia. Hey guys. Well, I'll be back in a minute because the proof is in the pudding. I've got to go downstairs and switch the circuit, the fuse breaker that I've currently got sitting in there for this one with this one, because this is better than the one that's in there at the moment. I've got to put that one back on my lights. No, it wasn't my lights. It's on the other side of my house, which right now isn't running too much. See you in a minute. In about 2-3 minutes. If you don't see me, then you know I've blown my house up.